Oftentimes when I talk about Quaternions on this YouTube channel, I follow it with some dumb joke about how mathematically bizarre they are. The W stands for witchcraft, etc. But one of the fun things about math, computer science, and game dev in general is that you don't always, and perhaps you don't often have to know actually how the inner workings of something work and able to make effective use out of it. So, hello all the crazy people out there, my name is Michael, I like wizards and dragons and making games, and let's talk about using Quaternions. So, I am not going to get into the utter witchcraft that is the inner workings of Quaternions, but what they are, for those who don't know, is a way of representing, among other things, 3D rotations in space. So, there is a series of 4 numbers, but unlike regular vec4s that you might or might not be familiar with in programming, instead of just containing 4 regular numbers, they contain 3 real numbers and 1 imaginary number. And this gives them some interesting properties. So, why might you want to use Quaternions? So there's a few things I've seen them used for in games, but by far the most common one is for dealing with a little situation known as gimbal lock. So if you want to represent a rotation in 3D space, what you'll probably try to do first is to just have 3 angles of rotation, 3 variables for angles of rotation. These are going to be rotation around the X, Y, or Z axis, or your pitch, yaw, and roll if you prefer aeronautics terms. These are your Euler angles, and yes, EULER is pronounced Euler. Don't get mad at me, it's not my fault. And if you rotate an object around these Euler angles, you might end up with something like this, where an object is rotating around the local x-axis, or... let me put that back to where it was, the local y-axis. Stand up, thank you. Or the local z-axis. And you can combine those. You can have an object move around multiple axes at the same time, like this. But there becomes a problem, and I'm going to go and reset this because I want all the angles to be 0. There comes a problem under certain circumstances where if you rotate an object, in this example, 90 degrees over the x-axis, if you try to then rotate it on the y-axis or the z-axis, so y is going this way, z is going this way, you'll find that they sort of degenerate into the same transformation, and you basically lose a degree of freedom like this. This is known as gimbal lock. It might be easier to visualize if I find one of those fancy gifs on the internet of like a spaceship and an actual gimbal that's rotating around different axes, and you can see that if you line it up in specific ways, you can sort of lock it to that rotation. This is generally something you want to avoid. This causes problems if you run into it. So I'm going to differ from most of the rest of the internet and say that I don't think this is actually that much of a problem most of the time. In general, if you're just rotating an object around like one axis, you using Euler angles is fine. You don't have to worry about gimbal lock if you're just dealing with one axis at a time. The problems really sort of become a little bit harder to ignore when you have an object that can at any moment rotate on any axis. If you have, for example, a camera that can pitch, yaw, or roll, or if you have like a spacecraft, if you're making a Super Mario Galaxy sort of game where objects can rotate in any direction. So if you're making a game in GameMaker or otherwise, don't immediately go ripping out your Euler angles. Anyway, there's a couple ways of dealing with this, and I guess just to look through my sample code, I don't have a very complicated sample project today. I am using the Skyrim chicken because I got a little bit bored of the test models that I was using in previous videos. Most of the code in the sample project pertains to, like, nice, smooth rotations. So that I can have smooth rotations and snapping to, like, 30-degree increments for the sake of the demo. And, of course, in the draw event, we are going and building a matrix from the pitch, yaw, and roll, or the X, Y, and Z rotation, whichever you prefer. So there's a couple of ways of dealing with gimbal lock. There's 2 main ways that I see. There's probably others that you can find on the internet elsewhere. One of them, which I'm not going to talk about, is instead of storing the X, Y, and Z rotation, you store a single rotation matrix, which you can then multiply it by another rotation matrix on, for example, the X, Y, or Z, and that is a valid way of doing it, but it's also not the point of this video. So what we are going to use instead is going to be Quaternions. So because I don't want to have to deal with the inner workings of Quaternions today, I'm going to use code that someone else already wrote to do it for us. And as is so often the case, the person who did that happens to be Juju Adams, because where would my life be without this guy? Anyway, so we're going to just go over to this GitHub repository that you can find linked down in the description. We are going to go to the Releases tab, and we are going to download Basic Quaternions YYMPS. That is going to give us a little GameMaker extension. I am going to open this, actually, I wanted to open the file location, didn't I? Why are we not downloading the file today? Is GitHub just, like, broken? Alright, well, better late than never. So we're going to go and open this in Explorer. I'm going to click and drag the .yympс into the IDE to import the local asset package. We can go ahead and do that. Yes, please. And we now can add basic Quaternions to our project. So you can look inside this to see what it contains. There's a whole bunch of functions pertaining to building and particularly rotating Quaternions. I am going to go and initialize a new Quaternion, saying quat, because I don't feel like spelling the whole thing out every time. I couldn't even do that, apparently, equals quat new. And this is going to go and... why do you not like this? Okay, is Feather going to give me a headache today? Okay, preferences. Have I, like, at some point... change my message severity to something that, like, I don't want it to be? Well, whatever. So this is our Quaternion. It is a data structure, which is basically just an array of 4 numbers. Nothing complicated, in much the same way that matrices in GameMaker are just arrays of 16 numbers. So all I'm going to do is I'm going to bounce over to the step event, and I'm going to look at... And I'm just going to leave my Euler angles alone for now so that I can, like, draw them on the screen what the values are. So if you increase the rotation about the x-axis by 2 degrees, I'm going to say quat equals quat rotate... I don't know why the rest of the functions that should be appearing in this dropdown aren't, but quat rotate local x. This quat rotate local x is going to take 2 arguments. One is going to be an existing Quaternion, which is going to be just the one that we're dealing with. And we're going to give it the angle that we want to rotate it by. And, alright, Feather, I swear to God, I try to defend Feather, and I try to tell people that it's actually useful and not utterly terrible, but when it does stuff like this, it really makes my job harder. I don't know why it's doing that. So, this looks roughly analogous to when you multiply one matrix by another matrix and you return the result of that in GameMaker. Same principle. We're going to just take the existing Quaternion, rotate it 2 degrees around the x-axis, and we're going to take the result, the Quaternion that's returned from that, and that's going to be our new Quaternion. And we can do this going in the other directions if we like. So when you subtract 2 on the x-axis, we can say quat rotate local x by an angle of -2. We can use the y-axis like this, and we can use the z-axis for the last one, like this. So this is going to be our Quaternion data structure, and it's going to be updated to reflect the rotations. But to actually do something with that, we are going to need to turn that back into a GameMaker matrix. And the way that we do that is going to be by saying quat get rotation matrix on that Quaternion. And now this is going to return a regular GameMaker 16 element 4x4 transformation matrix, which represents the rotation that we have defined. By the way, as tempting as it might be to do so, even though this is just an array of 4 numbers, you should never directly mess with the values inside that array of 4 numbers. You will get weird results in the Unity game engine, and I assume most other general-purpose off-the-shelf 3D game engines. Rotations are represented by Quaternions, and if you've ever inside Unity tried to set the X, Y, or Z of a rotation to an exact number, you'll notice that it gets very weird very fast. Anyway, so we can now turn this into a regular matrix. We can matrix set that to the shader, and the shader can use that. And now I can rotate you around the x-axis. I can go whichever way I want. I can rotate you around the y-axis. And I can rotate you around the z-axis. And in particular, I should have added a reset button to that demo, but I didn't, because restarting the game is just easier. Now if I were to line up the x-axis, or the x rotation to the y-axis so that it's 90 degrees, and if I were to rotate the y and z, we'll see that we no longer lose that degree of motion. This still behaves correctly. We don't have any rotations around any axes that just, like, look like each other. Okay, so that's great. So just for fun, let's go and see what actually happens if you do directly set a value of a Quaternion. So let's say that you, if keyboard check vk enter. If you just hit the enter key, we can say the quaternion, let's say that the x component, let's say that we want to directly just set this to 90, and we'll just imagine that this is going to do something useful. If I hit the enter key, it just disappeared. The values inside this quaternion turned into nonsense. I've seen a couple different particular types of nonsense that this turns into when you try to like directly set a value in a quaternion. So why this happens isn't really important, just don't do it. It's not how quaternions are intended to be used. What you can do if you want to create a quaternion that represents an exact rotation is you can use, and I guess I'll just go and keep the enter key here. You could use the quat from Euler angles function. And this is going to create a quaternion based on some rotation around the x, y, and z axes, or pitch, yaw, and roll if you prefer. Let's give you a set of angles that's like 60, 120, and I want a negative number. How about like negative 180? Something like that. And we can say quat equals that. And this is going to give us a rotation, if I hit the enter key, that it's a quaternion which is going to be built from those particular Euler angles. This is how you should go and create a quaternion from a particular set of angles if you'd like to do that. Can be useful sometimes. What you get when you just say quat nu is basically an identity quaternion, which is going to have a no rotation at all. That's like the same thing as just calling quat nu, just with it's basically an alias. All right, interesting. So there's a couple of other functions in here. From axis angle, if you want to create a quaternion which is just from not necessarily a rotation around the x, y, or z axis, but from any other vector in space representing an axis, and you want to rotate, if you want to create a rotation around there, you can use quat from axis angle. Quite a number of years ago, I talked about the Rodriguez rotation formula, and I believe that that's basically what this is, just like quaternionized. You have a bunch of housekeeping functions in here, so quaternion duplicate, quaternion equal, dot products, identity, invert, multiply. When you, much like matrices, when you do a rotation with quaternions, you're just multiplying one by the other. We also have slurp, and slurp is spherical interpolation, which is possibly the best name of anything in all of mathematics. This essentially lets you rotate between two angles, like, spherically. And slurping is super fun, and not just because I love saying it out loud. And that might warrant a video at some point in the future. So I think the last thing that I will talk about here is the difference between quat rotate local and quat rotate world. So far in this demo, I am doing all of my rotations in local space, which means that we're doing all of our rotations relative to, like, the chicken model. So if I rotate something around the z-axis, in this example, it doesn't really matter which way, like, let's go this way. It doesn't really matter which way the chicken is facing. If I rotate around the z-axis, we're always going to turn around an axis that comes out of, like, the top of the chicken's head. So that's local rotation. This is how most 3D, like, model editors or most 3D level editors work by default. However, if you want to rotate in basically world space, you can use quat rotate world instead. And can I just, like, search and replace so that I don't have to type out a bunch of things a bunch of times? I can. So this is going to allow me to instead, when you have no rotation, it's going to look the same. But when I rotate the chicken now, instead of rotating around axes that are coming out of, like, the top left and forward direction of the chicken itself, we are going to rotate, and it's probably easiest to see with the z-axis, we are going to rotate around the x, y, and z axes in absolute world space. If you do go into something like Blender, you can actually, so by default, we will rotate in object space. So if I rotate this cube, we will do all of our rotations. Oh, is it not default? Does it default to global space? Okay, I guess it does. So rotations in global space mean that if I rotate this cube around, like, this blue axis, the z-axis, it's going to rotate around the vertical axis of, like, the world. But if I choose local space, it will instead rotate around the vertical axis of the cube. And there are use cases for both. Like I said, I'm pretty sure that in most 3D editors, except for Blender, I guess, by default, you will be using local space. But it's good to know the distinction. Internally, all it really is that in local space, you create a new quaternion with that rotation, and you multiply that by the input. And when you do it in world space, you do it the other way around. Because much like multiplying matrices together, order matters. Quaternion multiplication is non-commutative, which is why, you know, I squared equals -1, j squared equals -1, k squared equals -1, ijk equals -1, which is a thing that wouldn't work in, like, normal person math. Alright, so is there anything else I really want to do here? I think that's about it. Other uses for quaternions that I've seen. So if you deal with, like, real-world things like robotics, you'll see quaternions here and there. In games, probably beyond dealing with gimbal lock, the most common use I see for these is for dealing with rotations in, like, skeletal animation. So when you have a 3D armature and you want to animate it and you want to, like, move the bones around and rotate them and stuff, you can store a 4x4 rotation matrix for each bone, which is going to be 16 values, or you can use a quaternion to rotate that, to represent that rotation, or I believe, which is more common, 2 quaternions to represent that rotation. And that 2 quaternions is just 8 numbers, which is like half the bandwidth you need to send to the shader when you set the skeletal animation properties. Hey. And inside the shader, you can convert the quaternions back into like a rotation matrix that you can use regularly. And I would like to talk about skeletal animation in GameMaker eventually someday. Whenever I do that, expect to see quaternions for dealing with that kind of thing. And I think with that, I'm gonna end this off here. So, my name is Michael. I like wizards and dragons and making games. If you want the code for this, look for the GitHub repository down in the description of this video. Although honestly, probably it's going to be more useful to go and look at Juju's Quaternion GitHub page, because that's what you really want. This demo isn't that interesting. Otherwise, I like to post videos about all kinds of stuff you can do in GameMaker, so if you're interested in weird 3D stuff like this, feel free to subscribe. I have a Patreon, so if you want to contribute to the channel, links to that can be found in all the usual places. This one actually was a Patreon request by someone named Paradox, who has been a bit of a long-time follower. You should all go check out Wizarducks and the Lost Hat, which, by the way, does not use quaternions for rotations, because pretty much nothing in that game will ever rotate around more than one axis at once, and it seemed like not worth the effort. Anyway, Steam page for that can be found down below as well. And as one final fun math fact for today, the guy who invented / discovered quaternions was named William Rowan Hamilton, and I'm 100% positively sure that the internet has never done anything goofy with that piece of trivia. Add another letter, see him now as he scrawls in the stone of a bridge like a revolution. IJK equals -1. Where I squared equals -1. Where J squared equals -1. Where K squared equals -1. Which equals IJK! William Rowan Hamilton. William Rowan Hamilton. We were waiting on the bounds for you. Waiting on the bounds for you. Your energy function generates the